Hello everyone, Dr. Zia Tahir here. This video tutorial is about 2D fixed beam with internal hinge analysis in ANSYS Workbench. The problem description: a fixed beam with internal hinge is shown in the figure. So that is a beam fixed at both ends, and there is an internal hinge here that's shown. The modulus of elasticity of beam material is 200 gigapascal. Poisson's ratio is 0.3. And second moment of area is 600 in 10 raised power minus 6 meter raised power 4. So to analyze, I'm assuming that as a square cross section with side as 0.2913. So with that side, you'll get that approximate 620 raised power minus 6 moment of inertia, second moment of inertia. So what is required here? Determine maximum deflection in the beam, plot bending moment diagram, shear force diagram, and vertical deflection under the loading condition. So these three are required. And this one is a modified version of problem 3.3 from chapter 3 beam elements from book Introduction to Finite Element Analysis using MATLAB and Abaqus. So it's here, problem 3.3. So from here, chapter number 3, and from the book Introduction to Finite Element Analysis using MATLAB and Abaqus. So there is a solution of this problem in this book. So the answers of that problem can be used to verify ANSYS results. So steps for analysis of beams. So these are steps in the project: start static structural, then engineering data, add material, then in geometry there is analysis type, and then using DesignModeler need to sketch that, and then in a model need to assign material, then perform meshing, and then this one specific is to how to create hinge in ANSYS workbench. Then in the model need to create construction geometry. This construction geometry will help to draw shear force diagram, bending moment diagram, and deflection curve. And the setup, static structural need to apply bound condition. Both are fixed boundary condition, and then concentrated force is required. Then the solution, total deformation is required to get maximum deflection, and then beam results, uh, shear moment diagram, so that is required, and then to solve it to get results, and then how to interpret those results. The first step is to start static structural project, and here is the workbench, and in workbench in the analysis systems. So need to start a project, double click on that, static structural. So that is a static structural project, and these are the steps in static structural which I have just described, and these steps I'll follow. I'm going to save that project in computer. So that project is saved. Next step is engineering data, add material for that workbench. Double click on engineering data, and then it is by default is a structural steel. I'm going to disable that, and then going to create a new material steel. So, and then from that toolbox, isotropic elasticity need to add there. And then here, Young's modulus is 200 gigapascal, and the Poisson's ratio is 0.3. So save it, and then you can close it. So material is saved. I'm going to close that, and then you can see there is a tick on engineering data. Next step in the geometry, select analysis type and basic geometry option, line bodies and analysis 3D. For that one, here click on the geometry, and in the properties, here the line body, click it, and then analysis type is 3D, although it is 2D analysis, but in workbench you have to select that 3D. And next in that is need to start design modular geometry, and for that one, right click on geometry. You have two options here: new space claim geometry or new design modeler. I'm going for design modeler. That is design modeler, and here you need to first sketch. for sketching, it is just a line with two spans as 4 meter and one as 6 meter. So here you have model and then the sketching. And in the sketching, go to setting. First, change the units to meter, and then major grid spacing 5, and then my max per major is 5. So I am going to draw it in XY plane. So for that one, go to draw a line. So line starting from origin, first 4 meter, then another 4 meter, and then 6 meters. So that is being sketched. So here you can add dimension in the display dimension. So dimensions, that is 4 meter, that is 4 meter, and that is 6 meter. So you can change dimensions from here. And then concept, line from sketches, and then generate. So once it's done, go to model, and here you have click on that. So it will select that one, concept, line from sketches, apply, and then generate. So now it is that is being beam as lines is generated. So the next in the concept, create a cross section, rectangular, and generate that. So cross section is so concept, cross section, rectangular you have, and sides are 0.2913 and 0.2913. So with those sides, you can see that its cross-sectional area is here 600 into 10 to the raised power 610 to the raised power, it is 6, and I'm going to rename that as rectangular and then create. So once it is being created, the next one, the line body, assign cross section and generate that. So line body and assign that as rectangular and then generate. And then I can see that if the cross section, to check the cross section, go to view, cross section solids, and you can see that here is the cross section for that one. So this is all like the line body is being generated. It's assigned cross section. So this all geometry part is done. Next step, we need to go to model and then start model. So here in the workbench, right click on that model and it will open ANSYS mechanical. It says starting mechanical. So that is ANSYS mechanical. And 6, 7. So they will be all will go in that window. So in the model, first we need to check geometry and assign material. So here there is a question mark on geometry. So line body and material is not assigned because the default material structure is steel and I disabled it. So select that one. So now that assigned to material steel is assigned to this body, and you need to change the units, and units are here the standard SI units I am using. Next step in the model, need to create mesh, and for that you need to define element size and then generate. So here is mesh, and I am going to set that 1 meter as element size, 1 meter, and in the mesh generate. So that mesh is being generated. In the display, if you want to see its cross section, so that is a cross section you can see, and that is a mesh. And here in preferences, node numbers, apply. Okay, so these are that is the model being meshed, and these are the number of nodes on that. Next step is to create hinge, and for that one in the model need to go connection, and in connection need to go end release. And for that one, for vertex geometry, select node, and then first you need to select that which node you need to release, and then any adjacent uh, edge need to select, and in definition need to set that rotation about z-axis as free. So for that one, here in the model, then in the model, here are connections, and in connection we need to select and release, and then for end release, so this end we need to release, which is at 8 meter. And for that one, here you have option. So it's a scoping method geometry, vertex geometry, no selection. So select vertex from here, and it is with the box selection. So that is the vertex. So apply, and then edge geometry adjacent to that one. Select from here edge, box selection, and that is edge selected. Apply, and then here rotation about z-axis we need to set as free. Rotation about z-axis need to set as free, because for internal hinges uh, we don't have any moment, so that one is all done. So now here you can see with the end release, so that is the end release, and now at this point 8 meters from left support, so a hinge is created. Next one, in the model construction geometry, need to create a path, and this path is required to plot bending moment, shear force diagram. So for that one, here in the model construction geometry path, and that is the path. And instead of 2 points, I am going for edge. And now from here, box select, to select all. Now that is the direction of path starting from 1 to 2, and that path is now created. Next step in the setup, static structural need to apply boundary conditions, and which are fixed supports, and in the environment go to support, fixed, scoping geometry, and then select vertex. So for that one, here in the static structural, so you need to fixed, it's a scoping method, so vertex, apply. So here you can see the fixed port. I am going to name it as left fixed port, and then similarly fixed. I'm going here, apply, and that one I'm going to rename as right. So both ports are fixed ports. They are added to that model. Step in the environment, loads, force, and the component and scoping method is geometry, and on the vertex. So 12 kilonewton load is applied at 4 meter from left support. So for that one, in the static structural, here you have force, and then scoping method geometry selection, vertex select is there, apply, and then defined by components, and minus 12 e raised power 3. So minus 12 e raised power 3. So 12 kilonewton load is being applied here. So that is 12 kilonewton load that is being applied. So that's the only load. Next, to find maximum deflection, I'm going to add total deformation, and for that one, go to solution and add total deformation in the solution. So that is the total deformation that is being added in the solution. This total deformation can be directional in y direction. It can be directional in y direction, but because there are no loads in x or y, x or z direction, so then the total deformation will be in y direction only. Next step, need to add in this for the solution shear and bending moment diagram, and for that scoping method is path, and we need directional shear force. So for that one, in the solution, beam results, shear movement diagram, and then it says that scoping method is path, and here is the path which I have created already, that path, and then in the total shear diagram, instead that I'm going for that one. So shear in y direction, moment along z direction, and deflection along y direction. So that is now for shear force, bending moment diagram, and deflection curve that is added in. So once all required parameters are added to the solution, so the next one is solve, and the solve is pretty much straightforward. Just click on the solution and hit solve button, and that all green, they will turn to green ticks. So here you can see solved. Next step in the results, need to find total deformation from the total deformation, maximum deflection is required. So it's very simple. Just click on total deformation, and that is the deformation curve you have, and click on maximum, and the maximum value is 1.58 millimeter at the hinge. So you can change the units here to millimeters. So that is 1.58 millimeter, and that maximum value is at the hinge. So at that point, or I can use that probe to find out that value as well. So next is to check shear force diagram, bending moment diagram, and deflection curve. And for that one, just click on here. So here, so first the units, I need to change it to the standard one. So that is the shear force diagram. Let me close that one. So that is the shear force diagram. Then that is a bending moment diagram. And you can see that the bending moment at hinge is 0. And that is the deflection curve in y direction. So you can, so that is a tabular data for that. So shear force along that length of the beam with the, so that is along the length of the beam, and then these are the graphs of that. So in this way, you can draw shear force diagram, bending moment diagram, and then deflection curve. So with that, this is end of this analysis. So in the end, summary of that all analysis. So this video tutorial is a little bit short, and for detail, I quickly went through. So if you want to learn more about basics of 2D beam analysis, so here are lecture 1 and lecture 2 in my playlist, ANSYS Workbench Structural Analysis. So whenever you have to perform any beam analysis, you need to start a steady state structural project. Then the next one is add material. So here I showed you add material, but there are some materials in the material library, so you can just select that material as well. Then in the analysis type, because it's a 2D beam, so basic geometry option, we need to go line bodies, and then need to select analysis type 3D. Once again, it is a 2D analysis, but if you will go for 2D analysis, Workbench will not work with that. And then need to sketch that. In DesignModeler, you have option of another option for space claim as well. So need to add cross section, and then you'll get generate that data, or generate that whole beam. Then in the model, need to, in the geometry, need to assign material, and then mesh using any element size. So it will generate that mesh. To create a hinge, you need to go connect in the model, need to go connection and release, and then vertex geometry, you need to select a node which you want to release or which you want to generate hinge, and then adjacent edge you need to select, and in the definition you need to set that rotation about z axis as free. Then to draw shear force, bending moment, and deflection curve diagrams, you need to create a path, and for that one, you need to create a path edge, select body as edges, And then in the setup, you need to apply boundary condition as both, so both are fixed, and then need to apply concentrated loads. Then in the solution, need to request total deformation because maximum deflection is required, and then to plot shear force diagram, bending moment diagram, and deflection curve. There is a built-in parameter. In beam result, you can add shear moment diagram. And then the solve, you can go results, the total deformation. For that, you can just check that where is the maximum deflection and its value, and then you can simply check that shear force bending moment diagram and deflection curve. So I hope you find this video helpful. Thank you very much for watching. So you can leave comments for your feedback, and for more videos on ANSYS Workbench, please subscribe my channel.